Good morning. First, I would like to thank the organizers of this meeting for accepting our proposal of oral communication. I will try here to summarize the results recently obtained within the framework of a research line founded by different organizations during the last years, focused on the analysis and the interpretation of Prehispanic wooden artifacts from the Canary Islands. As a brief introduction about the Canary Islands, we should locate ourselves in northwestern Africa. These 7 islands are of volcanic origin, and Fuerteventura, at the nearest point, is only 95 kilometers from Africa. Different bioclimatic belts are represented in the Canary Islands, from the infracanarian to the supracanarian and orocanarian in some islands. In fact, these islands present many microclimates with different landscapes and plant formations. According to archaeological and genetic data, the indigenous population of the Canary Islands originally came from North Africa. Radiocarbon dates of short-lived materials support an arrival of these populations to the Canary Islands during the first millennium AD. The way of life of these native island populations was conditioned by the absence of metal tools and their adaptation to volcanic lithic technologies and a new flora. Due to environmental conditions, there is a very good preservation of organic matter, which also includes evidence of wooden plant crafts. Our project focuses on the analysis of these wooden artifacts from an archaeobotanical and technological perspective. The most direct evidence of past woodworking activities is the analysis of tool marks on the surface of the wooden artifacts, as we see in these pictures. This is a research line mostly applied to waterlogged wooden artifacts. However, dry woods, as is our case in the Canary Islands, have a great potential to be analyzed from a technological perspective, since the manufacturing traces have a good preservation. This research line began in the Canary Islands in the framework of the Marie Curie Wood Traces project at the University of Basel, and now continues as one of the research lines of the Forest Impact Project founded by the Spanish Ministry of Science. The aims of this research line are related with the identification of the woody raw materials exploited and the technical processes involved in Prehispanic woodworking activities. Each artifact has been sampled for its botanical identification under a microscope by using the reference collection of the University of La Laguna in Tenerife. We created a protocol for the systematic analysis of these artifacts, and we recorded the tool marks, describing well the type of stop marks, the orientation, depth, and width using a binocular microscope. Last year, we carried out an experimental program with a total of 41 experiments aimed at documenting the tool marks produced in each action of the woodworking process, from debarking to polishing. We used different tools made of basalt, obsidian, bone chisels, and different woods collected in the Canary Islands. For each experiment, an exhaustive record was made on registration forms where we set out the protocol of the experimental program and where we recorded all the essential information regarding the woodwork, the tools, and the actions. The first days of the experimental program were dedicated to making lithic and bone replicas. We recorded every experiment with a photo and a video camera to record the movements and angles of each woodworking action. For each of the actions, different experiments were carried out using different taxa and tools. For example, during debarking, basalt flakes of different configurations and this lithic tool typical from Gran Canaria, called pic or pico in Spanish, were used. We also did experiments using fire to check if it made woodworking easier. The reproduction of the different actions of the chain opératoire allow obtaining the first experimental reference collection of tool marks for the Canary Islands. This first reference collection, which will be expanded in the coming years, is an essential resource to better understand the archaeological tool marks from the Prehispanic wooden artifacts. We have produced 3D models from this reference collection to ensure its future use. These digital models have also been made on small details of accidents, such as this example, which is the tool mark left on the wood. During these months, a database has been created to record the tool marks observed during the analysis of the experimental material. This is a long process, still not completed, but we can already observe some issues. First, fire must have been an important element in woodworking activities, as has been observed in many of the objects studied from several islands. It would have facilitated woodworking. We can also observe the use of fire aimed at opening perforations or associated to scraping traces in work areas. The stop marks from Prehispanic artifacts had a straight and a curved front, as we can see in these first two pictures, which initially led us to think that different tools were involved. But in the experimental material, we have observed that the same tool can produce different stop marks depending on the working angle. We tested direct and indirect percussion to observe the tool marks left. Direct percussion was very useful in some actions, such as debarking using a pick, since it allowed more control over the action being performed. This action left perpendicular tool marks on the wood surface, very frequent in Prehispanic artifacts. Indirect percussion could have played an important role in the roughing process. When indirect percussion was applied during the experimentation, some linear and parallel marks were usually recorded, probably due to tool dragging during the action. Tool marks produced during the final regularization of the surface are not very frequent in Prehispanic artifacts, with the exception of those where a specific final configuration was searched. During the experimentation, we reproduced facets with obsidian flakes and bone chisels. With bone chisels, we got facets closer to the morphology and size of some of the archaeological ones observed, but there are still experiments to be done in this way, since there are facet types that we cannot yet relate to specific tools. This experimental program was the first carried out in the Canary Islands with the aim of understanding the technical processes of Prehispanic woodworking activities. This research line will continue over the next years in the framework of a new project granted by the Spanish Ministry of Science, and we will focus future experiments on the technical processes involved in wooden containers manufacturing, which is one of the best preserved artifacts in different Canarian islands. Finally, I would like to thank the institutions and people who have made possible the development of this experimentation, especially the team that participated in the experimental program and contributed to shed light on Aboriginal woodworking activities in the Canary Islands.